Okay, in this video we're going to learn firstly about what is sound, and then about sound waves, because sound moves in a wave. So the first thing to do is write out a definition for sound. We've already learnt that sound is a type of energy. But it's caused by objects vibrating. And lots of different objects vibrate to make sound. One of the most common ones is a speaker. So there's a part inside the speaker that vibrates back and forwards, and it causes waves of sound to move away from it, away from the speaker. Other things that cause sound, like our voice box, that's a little part in the back of our throat that vibrates to make sound. And something like a car engine, there are parts in the engine that vibrate, and that makes the engine loud. That's the sound that we hear. Now this is only a simple version of sound, so now we need to look at more detail about how sound waves actually move. And the first thing to consider is that sound needs something to travel through. We all know that sound can travel through air. That's the most common way that we hear sound. So sound can travel through gases, such as air, but it can also travel through liquids and solids as well. And the reason it can travel through all these materials is that all these materials are made of particles. Particles are tiny objects that make up everything in the universe, or matter in the universe. And in gases, particles are quite spread out. There's lots of space between them. In liquids, particles are closer together. And in solids, particles are so close that they're touching and they're arranged in an ordered way. But sound can move through solids, liquids, and gases, as long as there are particles to move through. So let's look back at our speaker example. Here is a speaker, and now we will put in some air particles around the speaker. So when a speaker makes sound, it will vibrate back and forwards. Let's look at when it vibrates forwards quickly. So the speaker pushes forwards, and this pushes the air right near the speaker. All the particles of the air get pushed together, so they're bunched closely together. And this area has high pressure compared to the rest of the air. So where the particles are bunched together, it's called a compression. Because the particles are compressed together. On the other hand, here is this speaker when it vibrates backwards quickly. When this happens, the air particles get sucked away from each other and fill up more space so that they're spread out more. So that area is called a rarefaction. Where there is lower pressure. So the result of this is the speaker vibrates back and forwards really quickly, and it causes alternating compressions and rarefactions. So here is our first compression, then it alternates with a rarefaction, then we have another compression, and another rarefaction, and so on. So here are the compressions, and these move away from the speaker, constantly moving away, and then they alternate with the rarefactions that also move away from the speaker. Which means overall we have waves of sound moving away from the speaker. So sound is a wave because we have the alternating compressions and rarefactions, and it's a longitudinal wave, we call it longitudinal, because the particles are moving backwards and forwards. And this is something really important to just look at before we finish. We need to look at what an individual particle does. So looking at this one here, as the area around it gets compressed, all the particles nearby will move closely together. But then, as a rarefaction moves into that area, that same particle and all the ones near it will spread out again. But at the end, that particle is still in about the same position. The wave doesn't mean that every particle moves. It just means that the wave is moving. So the wave moves, not the particles. Not the particles. The final thing to look at now is just to remember that sound doesn't only travel in one direction away from the speaker or from the source of the sound. It travels in every direction. So if we imagine a table and we put a speaker on the table, the waves of the sound will move away from it in every direction, outwards. So the alternating compressions and rarefactions will move outwards in every direction. So sound waves move in every direction. In every direction.